Hello everyone. The title of this video is Using the Horizontal Line Test. So every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 3.1, called Functions and Function Notation, and I'm under the heading Using the Horizontal Line Test. I'm only doing a few examples here. Each example is either going to be an example from the reading or one of those try it problems from the reading, or one of the exercises from the end of the section that are related to this particular objective. All right. So yeah, I have them written out here. I'm going to be doing some exercises from the end of the section, exercise 55, 56, and 58, where we're asked to use what's called the horizontal line test to determine if the given graph is a one-to-one function. Now, I have defined a one-to-one function in a previous video. All right, a function is one-to-one if every output is paired with exactly one input. All right, so it's a function, so every input is paired with exactly one output, but one-to-one functions also work the other way around. Every output is paired with exactly one input. So I'll just say out loud the definition of one-to-one function here. All right, so the first thing you should do, before even using the horizontal line test, I would say use the vertical line test first, which again I did discuss in a previous video on using the vertical line test. First, I would use the vertical line test to determine if it's a function first off, to determine if y is a function of x. Because if you don't even have a function, you definitely can't have a one-to-one function, right? A one-to-one function is a specialized kind of function. All right, so first I would use the vertical line test to determine if y is a function of x. If so, well, I guess if not, you can stop the function, because if the graph isn't even a function, it definitely can't be a one-to-one function. Right? Now, if it is, right, if so, if yes, then we'll use the horizontal line test to determine if the function is one-to-one or not. All right, now the horizontal line test is very similar to the vertical line test, and I'll write out what you're looking for here. All right, so what is the horizontal line test? If any horizontal line, any one at all, now horizontal is left, right. Right? If any horizontal line intersects the graph or hits the graph more than once, right? If any horizontal line hits the graph more than once, then it's not the graph of a one-to-one function. Otherwise, if you can't find a horizontal line that hits the graph more than once, then the graph is a graph of a one-to-one function. Otherwise, it is a one-to-one function. All right, so a lot of writing here. Sorry. Yeah, because you know how every vertical line corresponds to an input, right? Every vertical line corresponded to an x value. Every horizontal line corresponds to a y value. And if a horizontal line hits the graph more than once, then that means there's an output that corresponds to more than one input. And if an output corresponds to more than one input, then the function can't be one-to-one. Right? Again, in a one-to-one function, every output corresponds to exactly one input, just like every input should correspond to exactly one output, you know, being a function and everything. Okay, so very similar to the vertical. All right, so example 1, I'm going to go over exercise 55 from the text. Right, so that's at the bottom. You know, you can read through this and read through the examples and junk, but exercise 55, scrolling down. And here we go. It says, you know, for the following exercises, right, determine if the graph given is a one-to-one function. Is y a one-to-one function of x? Well, 55, I mean, you got this oval, this ellipse here. So it's not even a function, first off, right? Do the vertical line test. It hits the graph. You know, I can find a vertical line. Just follow this dotted line up and down here. I can, you know, it hits the graph here and here. This isn't even a function. So it can't be a one-to-one function. It also fails the horizontal line test, right? Look, there's a horizontal line that hits the graph more than once as well. Right, go left to right. You're going to hit the graph at 2 points for a lot of these. So y equals 2, that output has 2 different x values that go to it and stuff like that. But first off, it's not even a function. Right, so it can't be a one-to-one function. So I'm gonna just draw a rough sketch here, right, of what, you know, just very, very rough of what we had. You know, it was this oval shape, right? And if I do the vertical line test here, you know, it hits there's a vertical line hitting the graph more than once. So, you know, y is not even a function of x. Y is not a function of x. Therefore, it's not a one-to-one function. Definitely, right? Because again, it's not even a function to begin with. And I hope that's clear. That's why I'm saying, you know, use the vertical line test first. Because if it's not even a function, you don't have to move on. Right? You don't even have to bother with the horizontal line test. Okay. Next example. Exercise 56. All right, so this one is a function. This does pass the vertical line test, right? You can draw any vertical line and it's going to hit this graph at most one time, right? You're never going to hit this graph more than once with a vertical line. All right, so this is a function. Y is a function of x. But it's not a one-to-one function. All right, draw horizontal lines. Go left to right. See this dotted line here where my cursor's following it at y equals 4. Right? Hits the graph here and here. So the output of 4 has 2 different inputs it corresponds to. So yes, it is a function, but it is not a one-to-one function, right? If it were one-to-one, every y value would correspond to exactly one x value. You know, drawing any horizontal line, you wouldn't hit the graph more than once, but here I am. So once again, I'll draw a very rough sketch of this. And we were given something that looks like this. It's like segment, an array, and a segment, and another array. Right? So again, you do the vertical line test. You know, this is a function, right? Y is a function of x here. Great. So if it is a function, the next question to ask yourself is, you know, is it a one-to-one function? Is it a special function? And that's where it's failing, right? Here's a horizontal line hitting the graph more than once, right? So a horizontal, as long as you find one of them. If you find any horizontal line that hits the graph more than once, the function's not one-to-one. So a horizontal line hits the graph, intersects the graph more than once, telling me that this, sure, y is a function of x, but it's not a one-to-one function. Okay. All right, and again, that's because, one more time, that's because there are outputs that correspond to, multiple inputs and not exactly one input, right? One more time. In a one-to-one function, every input corresponds to exactly one output, and every output corresponds to exactly one input. Say that a bunch, right? And finally, I only got a few of these. This is pretty simple in my opinion. Exercise 58, same kind of problem. Again, you can do these other ones, these odd number ones, but so there's 58, there's this graph. Now, it is a function, right? Passes the vertical line test. There aren't any vertical lines that hit it more than once, hit the graph more than once. So it's a function. Y is a function of x. And then after that, the natural question would be, is y a one-to-one function of x? So then I throw horizontal lines on this and go left to right, sweep. Every horizontal line is going to hit this graph at most one time. There aren't any horizontal lines that are hitting this graph more than once. So this is an example of a one-to-one function. Again, I'll do a really, really rough sketch here. X, Y, and it looked something like this. Yep. Right. Going like that, and again, passes the vertical line test. So y is a function of x. Cool. Right, it's a function, and then the next question to ask yourself, well, if it's a function, is it a one-to-one function? And again, now I'm going left to right here. I'm going horizontal lines, right? Horizontal lines, and no matter what horizontal line I draw, I'm hitting this graph one time, and no more than once. All right, so each horizontal line hits the graph at most one time. At most once, no more than once. So that tells me that this is a one-to-one function. Right? Is a one-to-one function. Fantastic. And again, it should be that easy. It should be that simple. Right? Again, do the vertical line test first. If it passes the vertical line test, then you got a function. Then ask yourself, well, great, I got a function. Now, is it a one-to-one function? So now you switch over to the horizontal line test, right? And once again, if you find any horizontal lines that hit the graph more than once, it's not one-to-one. Right? If you can't find any horizontal lines that hit the graph more than once, it is one-to-one. Every output would correspond to exactly one input in that case. Great. And that's it. Just a few examples, right? Those should be pretty quick. I feel that this is simple stuff. And I'm hoping that watching me go through these few examples here help you when you're asked to use the horizontal line test to determine if the graph you're shown is the graph of a one-to-one function on your own. And thank you very much for watching.